Eric's going to be talking about cross-site request forgery, which is one of the new items in the OWASP Top 10. Maybe some of you guys haven't even heard of it. So, but he's not about what is CSRF, but he's also going to talk about a new OWASP tool that he's going to release that will help you detect CSRF flaw in your application, and also 2 OWASP projects that can help you defend against CSRF attacks in your applications as well. So, very sure.
All right, guys, can you all hear me everything? This mic? Cool. All right, so actually, I'm kind of feeling good today. Right? So this is kind of fun. Being at OWASP, this is a great opportunity for engineers, for people in the field. Right? OWASP is a little different, right? We're about fixing problems, not poking holes. So even though I'm feeling good now, I wasn't feeling too good this morning. So the guys were laughing with me last night at Breach, the party at Breach. So if you guys ever been to a Breach party, I highly recommend it. So this talk is really just about cross-site request forgery in general, kind of what Dave mentioned. There's a few demos. I want to release, talk about some new tools that are being released. It's going to be pretty tight. So I'm kind of going to pull a Dennis Cruz here and talk really fast and move really fast. Sorry, Dennis, if you're here. So just kind of bear with me. So kind of the overview of this talk is we're really going to talk about brief overview of the same origin policy, brief overview of cross-site request forgery. I'm also going to talk mainly about 2 new OWASP tools that are going to be released either today or tomorrow, as well as some enterprise CSRF mitigation strategy. All right, so the foundation of the security of the web, right, kind of evolves around this thing called the same origin policy. So the same origin policy essentially says that JavaScript content from one site cannot modify or update the content of another site. And this is critically important for the internet. Right, so up here we have something at bank.com. And the idea is that the scripts at bank.com can't access the cookies or any other content at blog.net, or like JavaScript. The same origin policy also says that we can't issue out requests directly to that origin. Right? They're like XML HTTP requests. And this is critically important. If you guys think about if this wasn't in place, guys, the internet wouldn't work. The World Wide Web wouldn't work from a security standpoint. Kind of like nothing works from a security standpoint, it seems. Well, the whole web just totally wouldn't work. But with every security rule, it seems like there's exceptions. Right? And there are a few exceptions with the same origin policy. For example, bank.com can actually reference like images and other HTML content through tags at like a blog.net and vice versa. And this is kind of important in the sense that you're trying to reuse images, reuse other content without having to store it locally on the server. But this fact is very important as to how cross-site request forgery actually works. So CSRF. So CSRF is really the ability for me as the attacker to trick you, the victim, into submitting a request which has some action on the server. Maybe it's transferring funds, maybe it's deleting a user, logging out of an account. The idea here is that, let's say I'm authenticated at bank.com, I'm viewing my online statements, whatever. Right? And I hit Control-T in a nice tab browser which actually shares sessions between the two, and I then browse to something at blog.net. Now let's say there's something at blog.net that has some HTML in it, some tags, that when my browser parses it, it tells my browser to now issue a request back to bank.com, issuing for some resource. And typically we think it's looking for an image. But what if that URL of that resource is requesting is properly formed to carry out some action? Right? So maybe the first tag says, go to the transfer assets page. Select a fund. Select a from fund. Right? So that's the second tag. Maybe the third tag says, select a to fund. Select a dollar amount. Now your browser's issuing all these requests over to bank.com. And if the request is properly formed, bank.com is properly going to respond to these requests. Submit a transaction. Confirm the transaction. So the stuff that was on blog.net, all this HTML, it just told my browser to issue these requests for these resources. My browser, being liberal in what it receives, is just going to say, okay, let me issue out the request. It gets the content back and says, well, this is an image. Get ready. Right? The request was already issued. Right? So the server now carried out the action that the attacker had specified in these HTML tags. Oh, and I'm going to go fast, so if you guys have questions or Q&A, kind of save it for the end, or if we don't have time, take me up after the talk. So how does CSRF work? So there's a bunch of ways to go about carrying out the attack. The common ones we have up here on this slide. Right? So there's certain types of tags where you can reference some other external resource, and assuming you supply the proper parameters, the browser is going to parse this tag, submit a request for that resource, and it's going to carry out some action on your server. Interesting note here, XML HTTP request is still subject to the same origin policy, right? So I can't XHR from one site to another without breaking this policy. And the reason why this works, guys, is because the browser is going to send your credentials with every request. So if there's something at blog.net and it accesses some resource at bank.com, it's going to send my session ID, it's going to send my credentials. Your server's going to be like, okay, you're authenticated, you know, we're going to carry out that action, no big deal, right? And the problem is that since the browser is sending all your credentials with every request, your web application can't tell the difference between a legitimate request and a forwards request. So this is a pretty big issue in the web app stack world, right? So this sleeping giant, whatever you want to call it, it's got a lot of headway, got a lot of steam. So we as security pen testers, security analysts, you know, not the black hat, you the gray hat, white hat guys. We need a way to actually test it in all of our applications. Right, so that's one new tool that we're releasing at Aspect Security. A bunch of guys at Aspect Security, myself, Jason Lee, Jeff Williams, a lot of guys have come together and built this tool that gives us an automated way to test web applications to see if they're actually vulnerable to CSRF. So we can actually, it works similar to a proxy, or its foundation is a proxy. Think of like a web scare or a Peros or a burp proxy, right? So it's recording all the requests that go in and out from your browser to the web application. And then you can actually modify those requests that you recorded, click a button, and generate some HTML that would essentially carry out those same actions that you just executed. And if you're an attacker, what you want to do is then see if that HTML file has been viewed as another user, you want to see if those actions are still carried out. If you can do that, you can actually prove to yourself, you can actually generate proof of concept that your app is vulnerable to CSRF. So there's a bunch of different test cases that this tool has available to it. Right, so there's auto-posting forms, there's a classic link, right, where you have to kind of click it. There's image source tags, there's what we're calling an evil iframe, as well as a standard XML HTTP request. So before I actually release this tool, there's a couple things I need to clean up on one, maybe two of those examples. So here's just a quick screenshot of what it looks like. So essentially on this tool, up at the top here, you have all the requests that are recorded between your browser and the web server, or the web application. All right, and at the top here, you can actually select any request you want, and then at the bottom is populated all the query string parameters and form parameters that you can manipulate. So if I'm Joe Schmo and I'm trying to carry out a CSRF attack, maybe I'll log myself performing some transaction where I'm transferring funds from one account to another. If I capture that, I can now modify the parameters in here and change the to account, right? And I've changed the to account to my account, maybe change the dollar amount, and change the from account to some victim. Then all I have to do is select the report type that I want. Maybe I want this report type to be carried out using image source tags. Maybe I want this report type to be carried out using XHR, and that's maybe a stored cross-site scripting vulnerability in the site. And then I click this generate HTML button. So when I generate this HTML, I get this nice little file. And then if a user is actually tricked into viewing that HTML, maybe I store it on some site like a blog site, or I hand it off to one of your users and say, hey, can you take a look at this? Your browser's going to parse that, and assuming they're authenticated and I've properly formed the request, this attack, or this test case that we just generated, is actually going to be carried out. So I'm going to actually go ahead and show you, run for a quick demo on how to use this tool. So, sorry, the camera guy. No, I think he gave up on me because I kept moving. All right, so if you guys haven't heard of WebGoat, shame on you, right? So this is a pretty cool tool that you can use to teach other security engineers and to other security people about these kind of issues. That looks really bad. So what I did was, on a train ride back from a customer site, I actually went ahead and implemented some new, what we're calling labs. Basically, these are like coding labs or a coding environment that gives you the ability to demonstrate CSRF attacks and prove that, and test some fixes against CSRF attacks.
I want to lower your resolution.
Is that
Go to your desktop.
Or press control. Or you can just do control plus.
Let's go to your desktop. You probably can't wait for presentation. Just go ahead and control panel. Display. There it is.
Alright. So even security engineers are kind of done something good. Alright, so on this particular lesson here, the idea here is we have this fake bank called Goat Hills Financial. And it manages all these users. And it gives them the ability to actually view their profiles, update their personal profiles. It goes a little bit more robust. It gives them the ability to access their own accounts, maybe view certain transactions that they've carried out. And in this, there's actually a hierarchical role set implemented. Right, so there's normal users, there's managers, there's HR people. And we want to actually test and see if we can carry out a CSRF attack against this particular application. Now, we break these things down into stages, and if you guys have ever been in aspect training, this will probably look familiar. Right, so stage one basically is asking us to log in as a particular user, generate a CSRF attack that when viewed will modify someone else's profile to whatever you want. Right? So let's go ahead and see if we can't do that. So according to actually pass this stage, I'm going to log in as this user, Eric. Select myself, I'm going to click View Profile. I'm going to click Edit Profile. Alright, so me as a test person, I've found a particular business function that I want to test for CSRF. So what I need to do now is go back to the CSRFTester, which is right here. And I want to start recording the actions I'm now going to carry out. Alright, so in order to do that, I just click this button up top that says Start Recording. I mean, pretty simple, pretty straightforward. Kind of ugly swing, but it's very easy to use.
Yeah. You've reconfigured this to be a proxy already at this point?
Yes. Yeah, so in order to get this to work, basically you have to instruct your browser to first go through CSRFTester, which then will go to the web code application. So kind of a leap of faith I took there. Alright, so now I go back to the particular business function I want to test, and I invoke it. Right, so I'm just going to click this Update Profile button. Once I click that, you'll notice now that the CSRFTester has one request loaded in. Some actions could have span multiple requests. This particular one, for simplicity, is just one. So I'm going to go ahead and click it here. You notice that now I have all my query string parameters and my form parameters listed out below. So I'm going to actually go ahead and modify some of these form parameters. So I'm going to change the first name to Bruce, let's say. In order to get this to work, I actually need to change something called employee_ID from 104 to 108 because I'm attacking Bruce who's 108. Might be an access control problem there. And to actually pass the lesson, I have to actually change the street address to CSRF attack. So this is a really mundane example, but if this was being carried out in the real world, I can change it to whatever I want. I can make your profile say something that's quite disrespectful. Look at this viewed. Maybe I can offend other coworkers, so that when your profile is viewed, people think you said it, right? So now that I have all my parameters the way I want them, I'm going to go ahead and now generate a report, which will be my test case. So the first report I'm going to do is I'm going to just do the image source test case. This is kind of the classic CSRF example, or it's quickly becoming the classic CSRF example. So click Image, and you can optionally display this in your browser, whether you check or uncheck that box. If you check it out, I think by default opens it up in IE. but I wanted to work with Firefox, so I'm just thinking unchecked for the moment. Click Generate HTML. Specify where you actually want to store this document. And I'll just pick the desktop, and I'll click Save. Right, so now I've actually saved off this particular request using into an HTML document that, when viewed, will transmit this request and cause some action to happen on the server. So we can actually look at this document. That's probably hard to see, but the important part up there is near the top, right? So there's an image source tag, and the source is actually the URL of WebGo with all the parameters needed to run the update profile action with the values that I've specified. Sorry about that. I sound like a girl. I usually hit myself when teaching or talking. All right, so now to verify this attack, I'm going to log back in as a person I want to be attacked. All right, so let's say our name is Bruce, and we're logging in and we're doing whatever on our Goat Hills financial site. Right? Usually when we're doing this kind of stuff, maybe we get bored and browse off to some other site. So let's say, hit Control-T, another tab, and now I'm viewing some other site that happens to have this HTML stored in it. Right? And to kind of simulate that here, I'm actually going to open up the file, the HTML file that was stored on my desktop. So this is all we see from the HTML file. We have really no visual evidence that anything happened except this big OWASP CSRFTester demonstration. In the real world, if you guys got hit by a CSRF attack, you wouldn't see anything, right? I mean, if you look at your view source, maybe that'll help you. But I don't know too many people digging around view source on these public web pages. So if this worked, I should now be able to go back to Bruce and click my view profile button. And when I view my profile, it should be changed to something like CSRF_attack or whatever values I may have specified. So it looks like it actually worked. Right? So my profile as Bruce was updated while I was surfing the internet. And it's just because this HTML was stored off-site in some other location. Right? So that's one type of report that you can generate. Another one you can do is actually, you can make use of, I'll just run the forums example. Right, so you can do auto-posting forms. You can have a series of forms. Right? If it takes 5 requests to have some action occur, an HTML file with 5 forms in it. It just says auto submits all of them. So I'll actually generate that report with this particular attack. So if I log back in as Bruce and run this new example, I'll just get refresh. And with auto posting forms, I actually got, once I submitted the request, Firefox actually took me back to the main page, and we can see here that the attack is still firing. Right? If we were to look at the source of this, well, it's HTML. I don't think it will bore you guys too much with that. But conceptually, I think it's pretty clear how you can actually build test cases when you're pen testing your applications for CSRF. So if an attacker can find a CSRF problem on your site, they can do pretty much whatever they want. They can do whatever an authenticated user of your application can do. Right? The actual attack vector is really limited to what your particular application supports. And a lot of interesting examples that we run through when we're performing these pen tests is doing multi-stage actions or transactions through some wizard interface. I always hear people tell me, Eric, you have a nice confirmation button, so you can't hit that. Well, I can generate a request to click that button, right? And an interesting note, think about what this does on accountability. Right, so at OWASP, we have this really cool logging project. Right, so we got this group out there that's building all this criteria of how to log stuff, right? All these best practices, things to include. But if our application is vulnerable to CSRF, what confidence do we have in our logs? Those log entries they're now going to reflect the actions that victims were tricked into executing. And if your application is vulnerable to CSRF, you can't be that confident in your logs. That confidence level goes significantly down.
When you talk about limited on what can be done with data, are you referring to, I mean, you can't just look at cookies for other names, for instance.
Right. So there is a lot of limitations. So you could fetch requests and get the response back depending on the scenario, how you fetch the request, whether or not the browser is supporting the same origin policy. You may or may not be able to do something with the data. Right? You may be able to post it off on your site or some other origin. But this is kind of really depends on the browser and how well it's enforcing the policy. So Jeremiah Grossman and Arsenic are pretty big about showing cross-site scripting attacks and how they can actually affect internal applications. Well, I don't think this is too hard to this leap isn't too hard to make, but CSRF attacks can actually attack your internal applications as well. Right, so if I'm browsing around, let's say I'm on some site called attacker.com, and I'm an internal employee, as you say, eBay. Right, so I'm at eBay here, and I'm browsing around attacker.com because I'm just a malicious eBay employee, and I've used some tag that when interpreted, tells my browser to issue an internal request. This actually says internal.mybank.com, but wait, what if it's like hr.ebay.com? And if that request is properly formed, again, there's no restrictions here. The attack is actually going to fire off against an internal site. If this were Black Hat, this presentation would be over. You guys have ever gone to a Black Hat conference or a Black Hat talk? These guys love just going around poking holes in things, and then that's it. Right? They just walk away. Hey, here's a problem. And they just kind of go off. But this isn't Black Hat, right? This is an OWASP conference. And what's cool about OWASP, right, is we don't just poke holes, laugh about it, and then walk away. We don't just spread FUD and then that's it. Right? At OWASP, we actually offer mitigations. We actually offer compensating controls for these issues. Right? That's kind of a good lead-in to the next tool I'm going to talk about that is being released at OWASP. So there's a lot of misconceptions on how to deal with CSRF. A lot of these examples we have up here do have some effect. I'm just saying they're not bulletproof, but it can make it harder on an attacker, right? It makes them jump another hurdle. One interesting recommendation that I saw was this URL rewrite. Right, so the idea of putting a cookie up in the URL is maybe kind of like a parameter. And the idea here was that if the attacker doesn't know your session ID, they can't craft that attack and build that HTML file or build that test case for arbitrary victims. Right? Because in order for that to occur, I need to know your session ID to carry out this attack. So this obviously isn't recommended for the usual session ID exposure reasons, about all your logs and client-side caching, all that good stuff. But conceptually, this is pretty important. Right? So if we can implement something in the request that's unique to the request that the browser doesn't automatically send, that an attacker can't guess, then they can't build these CSRF attacks. So the second tool we're going to talk about is the OWASP CSRFGuard. So version 1.0, I think, was released earlier this year. It was really just a proof of concept. I apologize to anyone in here who had to look at that code. Your eyes probably hurt. It was kind of ugly in one of those methods. But the 2.0 was a total rewrite. And I actually did it like I think a good developer. Right? I thought about robustness and flexibility and applying it in different environments. So let's just kind of walk through what the CSRFGuard does for us. The CSRFGuard is actually a J2EE implementation of this idea of a unique request token. A J2EE filter is basically something that sits in front of your web application and can intercept all the requests going in and all the responses going out. And it gives the filter the ability to modify either the request and or the response. And this can be almost totally transparent to your application. But as you have your business logic, you just throw this little thing in front of it, which actually offers some decent protection. Right, so when your browser issues a request to an application that's protected by the CSRFGuard, the request is first intercepted by the CSRFGuard, and CSRFGuard actually looks for the existence of a parameter, a unique request token. Right? If that token doesn't exist, or it fails a validity test, your request is now subject to a series of defined actions. Right? If that token isn't there or is malformed, that's basically telling me, the filter, that there's a CSRF attack occurring against our application, or there's a possible CSRF attack occurring. Right, so CSRFGuard comes with 3 actions by default. There's a logging action, pretty clear. There's an invalidate action, which will invalidate the user session. And then there's a redirect action. So the cool thing here is, I supply these 3 examples, and in fact the demo I'm going to show you makes use of all 3 of these. But you can actually make your own actions, right? So that's one of the difficult things about trying to make something that can be used in various environments, is there are support issues and determining what to do when an attack occurs. So once the request passes our validation and the response goes out, CSRFGuard will actually modify the HTML and insert this unique random request token throughout the HTML. It actually goes about doing it 3 ways. The first way, what we're going to call the old school way, which is 1.0, actually use regular expressions to traverse your HTML and insert the token. It was pretty fast. Accuracy, I heard good things, never really anything negative, but the code is really ugly and hard to maintain. Note also that this is being performed on the server side. The second response handler that you can use in CSRFGuard actually makes use of an HTML parser. If you choose to use the HTML parser, you actually have a lot of power on the server side to modify the code, manipulate the HTML however you want. Nice, easy to use interface. The bad part here is parsing HTML is a very expensive operation. There is a significant performance penalty on your server side if you're going to be modifying the token using HTML parser. The third option we have here is actually adding the token into the HTML, but on the client side using JavaScript. So when that response goes back, your browser will get the response and say, oh, I need to run this JavaScript function. And this JavaScript function will go ahead and update all the links and all the forms on your page to include this random token. So it'll actually go forward and add the token to all the source attributes, the href attributes, add a hidden field to all your forms. And this is great for performance. Let's offload the work to this really cool browser that are pretty fast. So from a server side, performance-wise, things are kind of run along smoothly. Let's actually do a demo. That's a horrible demo slide, so I'm going to go back to that.
How does the server know that's the correct token? Is it passing that part of the client source saying token? Now it's your job to go to the source to where it needs to be, or where's the verification?
Yeah, so when the request comes in, if there was no, so it's actually storing the token in the session. Right, so if a request comes in and there's no session or there's no token in the session, CSRFGuard will actually automatically generate that token, store the session, and then begin adding it to all the HTML. Now for every,
All that stuff you just described is all on the client side, or
well, this is all on the server side. So actually, so the verifications on the server side, adding the token to the HTML can be server side or can be client side. It's kind of can we pull off really fast here? I'll get you that. All right, so let me run through a demo. All right, so in order to set up the CSRFGuard, the first thing you have to do is actually make some entries in your web.xml file. So I actually have right up here, this web.xml file describes how your application, your container should actually deploy this particular application, what servlets are to be handling all these requests. So basically what I did here is I defined CSRFGuard. I pointed it to a properties file, CSRFGuard properties file, which describes how it behaves, and also mapped it to protect a servlet called WebGo. Right, so WebGo is kind of the core servlet or the core application that we're using to demonstrate here. Now, CSRFGuard also has a nice little properties file, again, which describes how it should be run. So here's just an example, but the important parts here is in this file you can define what kind of response handler you want to use, right? Whether you want to use JavaScript or HTML parsing or regular expression modification. You can define a series of actions that you want to have take place if a potential CSRF attack is found. And in this example here, the actions I'm going to have in order are log the request, invalidate the session, and redirect the user. Now, from a usability standpoint, that's not the best idea, right? If an attacker can find a CSRF vulnerability in your site, generate the request, and you catch it, but you invalidate the person's session, that may be enough for the attacker, right? Kind of a denial of service. But I'm using this just for demonstration purposes, so you can easily see the effects of the tool. All right, so in order to install this, I'm going to stop the server, and I'm going to run a nice little batch or ant script file here, which will compile the jar, copy it into the correct location, and update the web.xml file. So now that the changes are in place, I go ahead and start the server back up. All right, so I'll go to stage 2 here. Now, stage 2 on this lab basically says implement CSRFGuard and run the same attack you did in stage 1 and verify that it's actually your application is defending against it. So I'm going to log back in as Bruce here. And now I'm going to load up that same HTML file that automatically posts those forms. And it automatically posted the forms, but notice I landed back on the main page. I landed back on the main page because the server caught the attack, it logged it, and validated my session, and redirected me all the way back to the logger page. Now, if you go look at your application containers log files, you'll see an entry in there that says, possible CSRF attack detected from this IP at this time, with this prefer header, with these parameters, and so forth. Right, so now you have a nice way to implement accountability for people who perform this attack, and you can defend against this type of attack so you still have confidence in your logs, which is kind of important. Now if I click Start Web Code again, and I go back to the stage and click stage 2, I didn't get my nice green check, but if I wasn't such a lucky programmer, I get a nice green check showing that it actually worked. So there are similar implementations out there that kind of follow the scheme of generating a random token, validate it on the way in, add it to the response on the way out. There's a PHP version of CSRFGuard available at OWASP. There's also another PHP/JavaScript implementation called JSCK. You guys know where this screenshot came from? Come talk to me. I love this game. But yeah, so the idea here is, let's think about how CSRFGuard and cross-site scripting kind of conflict here. So this slide actually has a demo, and I think for time purposes I'm going to skip over it conceptually. I don't think it's too hard for you guys. It's not hard for anyone to digest. But with cross-site scripting, there's some nice little side effects with the CSRFGuard. So let's first think about reflected cross-site scripting. With reflected cross-site scripting, in order for that attack to occur, I usually need to give the victim a link to click or generate some HTML that the person has to interact with. Right? That's the common case. If I don't know your token, I can't craft that HTML. I may still have the vulnerability up on my site, right? But if I don't know your unique token, I can't craft the HTML that you run, and when the request goes to the server, it actually never hits that vulnerable location in your code, because the token wasn't right or wasn't there. And then some error occurs, maybe you log it, and the action's never run. So there's a nice little side effect here, right? So a lot of reflected cross-site scripting attack vectors are put to rest if you have a CSRFGuard protected application. However, if you have a stored cross-site scripting vulnerability in your site, and an attacker can store script in there, there's nothing stopping them from having their script parse out this unique random request token in the HTML and then submitting it with every subsequent request. Right, so there's a little bit of a downfall there. So the assumption here is, CSRF is a pretty important vulnerability or issue that you have to deal with, but it's about as important as cross-site scripting. But if you have a stored cross-site scripting vulnerability on your site, this CSRFGuard really can't help you. I'm sure there's a lot of consulting companies who could help you, but this thing won't. So the demo I had was just to basically show you that CSRFGuard can bypass the web code using some JavaScript. I'm going to skip it. I think you guys are following along with me on that. So the big problem really comes now for the organizations who are trying to deal with this threat. So picture yourself as a big organization with a disparate set of project groups, development teams that are kind of like the renegade cowboy programmers. Right, up till 3 a.m. in the morning, cranking out code left and right. No real process, just fun and so kind of profit, right? Developers usually on that page. So if you have an organization like that and you're kind of leading that group, how do you go about fixing this problem throughout your entire organization? That's a really hard problem. This is not an easy thing to fix globally. right? So the approach that you should think about is understand that it's really a balancing act, but it requires a well-defined and thought-out strategy, right? So, there are certain fixes that will knock out CSRF, like theoretically are bulletproof, right? Will stop CSRF. But from a usability standpoint, they suck, right? Your users will get really upset if they have to carry out these certain tasks all the time if they want to execute a function. Then there are certain tricks that are pretty strong at stopping CSRF, like OWASP CSRFGuard, but kind of fail in certain cases. Right? So for every organization, there's really no right strategy. It depends on what your drivers are, what the development team's like. But if you run into the situation, you have to offer advice or actually go out and implement these fixes globally throughout your organization. There's a couple key things that you want to remember, you want to kind of think about when you go about implementing this solution. First thing you want to do is actually gather information, right? Know what kind of development teams you have, know what technologies they're using, understand what applications that they're using, try and get an understanding of the risk associated with these applications. And if you don't have a nice training program in place and your developers really aren't up to date or aware of these issues, now it's the time to start raising that awareness. Right? So when you actually go around gathering this information, say, guys, we're doing this because there's this huge threat and it's giving us some problems and we need to mitigate it throughout our organization. Once you do that, once you get a collection of the applications, the tools, and technologies, then you want to start thinking about prioritizing those high-risk applications. Right? What are the most sensitive applications that we need to protect in our organization? At eBay, maybe that's eBay.com. Right? What business functions are absolutely critical for us to protect? And once you define and prioritize what you need to fix, you now have to actually go ahead and implement a security solution that's visible but transparent. Right? I stole that, I think, from Jeff Williams, or was talking about it earlier today. So, with the idea that clearly you're protected, but it doesn't really affect usability. And that's where the balancing act comes in. Now, that's a pretty big leap to make, right? So there's a bunch of things you have to think about, like, can I do like a drop the code in, configure and deploy kind of approach with my technology, like you can do with like J2E or .NET, or is this going to require code changes throughout all of my applications? Right, so these are major things you guys now have to think about. This isn't an easy, let's just encode all the output, which that seems not really easy either, right? So there's a bunch of things you now have to think about. So I kind of broke this everything down into this nice little colorful areas. Like I really like Office 2007. So at the top here, I have something that says mission critical functions. If you have mission critical functions and you need to protect, think about like challenge response protocols, like a CAPTCHA, or maybe one time like RSA token. You guys, when you all came in here, you should have gotten an eBay time token. That's a pretty good defense against CSRF if you can require that. But if you had to do that on every single business function, usability sucks, right? People aren't going to use the app. For your everyday business functions, consider implementations that don't require major code changes, but where you can still get some effectiveness, like a unique request token approach, right? There are special cases there, but from a prioritization and cost and usability, this approach, this fix may make sense based on our risk and our assessment, our kind of threat model of the organization. And then you have this third, which I'm calling the lunch menu functions, which are just kind of like, you might as well have just silly things that it may not be worth the time or the money to go invest and fix. Right, so I think I've hit it almost perfectly. I'm flat out of time. If you guys have questions, just come up and see me. Otherwise, thank you.